Brooklyn and Jordan, y'all are not even remotely talking about math. Fix that. Wesley, have you written any equation yet? Let me see it. Let me see it.
Oh, we got.
You haven't even shown it to me yet. Show me your equation. How is the y-intercept 3 when it's not a positive y-intercept? You wrote something random down. Quit doing that. So you do know where to start. What are we trying to create? You do know what are we trying to create. I'm not asking you what the final answer is. Well, you have a line. You're trying to create the equation. That's literally the problem. What is the general equation line? You should start there. You're not even close to the same group. Turn in your desk, Jordan, until it's a whole class discussion time. You're not even giving yourself a chance to do this problem. Have you finished this problem? Everybody in your problem done? Question? Your group done? Then you need to check on them. You're responsible for each other's learning. Devin, don't forget to put your phone up, bud. Alright.
He got it. He made me understand.
Stop it.
Alright, you need to have your answer in within the next 30 seconds. I'm stopping the poll question in 30 seconds. 20 at this point. I now only have 17 of 25 students with answers in. Means 8 of us need to start typing and hit submit. Yes, ma'am. But you haven't even typed in the equation yet. Alright. Sorry. So, let's look at it. IDK, I'm confused.
I wrote that like
That's not true. There are numbers. 1, 2. The IDKs and the I'm confused. I don't know. Could you have talked to somebody in your small group to see if you could come up with an answer? Could you have asked me, Mr. Kinney, for help on this? Y'all are too busy sitting there struggling and giving up on yourselves that you're not taking advantage of the resources you have. And also, there's a whole bunch of us that should have notes and we don't have notes to rely back on. Because I have gone over this type of problem every day for the last, I don't know, 6 days of class, except for one of those days. Guys, we got to take advantage of the resources we have. I cannot help if you're not doing what I ask you to do. First things first. We're trying to write the equation of a what? Of a line, of linear function. What is the first thing that you should have done that most of us did not do?
The equation.
Write the equation. Because here's the thing, you could create a graph, right? Do you have to though? No. But what do you need? The equation. And I'm talking through things and explaining things, and people that said IDK or I'm confused are not writing this down. I'm getting irritated at this point because you are all capable. This isn't some gimmicky thing where I greet you and I ask you to tell me that you're capable when you walk in because I'm doing it for kicks and giggles. I'm doing it because all of you need to remember and need to understand that you're capable of amazing things. But when we don't put in the work and the effort, when we don't take notes on the things that I teach you, it's going to be hard to grow and learn. I hear a lot of conversations that have nothing to do with the mathematics in my classroom. If you're having conversations about things that don't deal with my classroom, then you're going to struggle because you're not putting in the time and effort that I need you to put in. I have 90 minutes a day to try to teach you as much as possible. When you walk into my class, from when you put up your phone till the time when you get your phone as you walk out of my class, the conversations need to be purely about the mathematics that we're learning. And when you do that, you're going to grow and you're going to learn. And I need you to understand that I get it, that it's not always going to be easy. You saying that I'm capable does not mean that everything's going to come quickly. What it means is that you are capable of growing and learning, which means you are capable of mastering eventually. Hard work pays off. But not all of us are putting in the hard work to grow and learn. You're capable of amazing things. Step up. Do the work that I ask you to do. I know it's a pain to do work. Trust me. I'd rather be sitting at home watching Netflix than teaching because that's easier than work. I get it. But at the same time, your education matters. And we need to act like our education matters. So looking up here right now, we've already said we need the equation. What is the equation of a line? Y equals mx plus b. You write that because, again, I've talked about this in the past, you need a roadmap of what you're trying to get to. Okay, I'm trying to get to the equation of a line. Here's my roadmap to get there. This should instantly tell me the important things I need. I write this out. So what do I need to try to find next? Well, I'm going to do that in a second, but I want the slope. So do I need points? Maybe. When I look at this graph, I designed it this way to maybe make it a little bit harder. Because we need to be able to think through these things. But we need to be able to identify clear points. There is graph paper up here, and I will get more graph paper if I need to. If you're doing a graph, don't do it on lined paper. Do it on graph paper. So what is a point that we can see on that graph? Any point.
Six. Where did you see the 6 at?
5.
I see a 1.
I do. So look, follow along and look for an intersection of a grid. I see the line hitting the grid right here. 6, 1, 1, 2, 3, 4, 5, 6. 1 would be up here. I see 1, 2, 3, 4, 5. 1, 2, 5, negative 2. I see that point. So I'm going to continue along. And I will say this. It's going to be hard to see it up here. You might want to look on your... actually, I hit stop, didn't I? So you can't see it on there anymore? My bad.
Excuse this interruption. Can we have Tomorrowland Madison to the office for a moment, please?
He's on his way.
Thank you.
That's the only other clear point that I see. That's 6, 7, 8, 9, 10. 1, 2, 3, 4. 10 comma 4. Can you find the slope between those 2 points?
I think so.
How do we calculate slope? There's 2 different ways.
Rise over run.
Rise divided by run. Rise divided by run and change in y divided by change in x. So, how much is it rising? 1, 2, 3, 4, 5, 6. That's it. Notice how it's going from -2 up to 4. It's going up 6. How far is it going to the right?
5.
So is it adding or subtracting?
You're adding 5.
So what's my slope?
5 is almost done.
We need rise first. 6 divided by 5. There's my slope.
Wait, I tell you find slope.
Yep. Rise divided by run or change in
I
y.
can see any point.
But Joey, I didn't label the points for you. You had to identify the points. You have to look and identify where that line shows up on the grid. Let's do this. I'm going to send it back out. Sending it back out as a poll question. I want you to look on your document there, and I'll try to make it bigger in the future, but look to see if you can find where it's 5, -2, where it intersects the grid. What's going on? Brooklyn, you looking to see if you can find those points? Do you see those points? Are you even trying? What do you mean you're confused? Okay. If I can grab your attention. Hey, listen. Because this is a good question that Jordan's asking. He's asking, where is this 1 coming from? Does anyone know what that is? It's not the origin. Well, it's not just that. That 1 is just telling me what the scale is. So if this is 1, what's the next line? 2. 2. The next line, 3. If this had been a 2 though, Jordan, if that was 2, then what's this next line? 4. 4. Because it's telling me that it goes by 2s. That's just all that is doing. It's telling me the scale. Okay? And so once I see that, and so I'm glad you brought that up because I didn't realize that was a misunderstanding or a thing we didn't know. But that's just indicating that every block is 1. That's it. But we need to look along the line to find where the line intersects the grid. Anybody have a question about it being 5, -2, or 10, 4 now?
I still don't see any point.
Okay, the points are not there. You have to identify them on your own. I'm going to make this a little bit bigger here. Look. So Joey, if I come along this line, tell me when you see a clear intersection with the grid. See right there? It's close here, but the grid intersects there just above the line. Here the grid is just below the line, but right here, that line intersects the grid.
I want to do that thing with like they just now crossing, you know, like that one was going up and down, right? That one was side to side, they crossing each other. Why don't we put anything like that?
You talking about the origin right here?
Like oh, on the other one.
I don't know what you're talking about.
These right here. Yeah, in between right here. Right?
Come up here. Where are you pointing?
Why don't you just
Okay. First off, so grab a seat. Anybody know what that point's called?
X-intercept.
That's called an x-intercept. But Jordan, can you see exactly what that value is right there? No. That's why we're not using it. Can you? Sure. But if I don't know exactly what it is, there's no point in using it. Does that make sense? Okay? So Joey, I'm going to continue along here. And, okay, let me clarify something, because I think this is a misconception actually that a lot of students have. Does anyone know how many points are on this line?
No.
Okay, let me show you this then, because I think this will help some of the confusion. Can I draw that point right there on that line?
No.
I mean, that's on the line, isn't it? Yes? What about this? Is that a point on the line? It's on the line. What about this? Is this a point on the line? It actually is. So I need you all to pay attention to this because I think this is where a misunderstanding is. Hey, Jaden, are you paying attention, dude? Because you're busy looking at your wristband and not up here, and it's hard to learn when you're not looking up here. So, I've just drawn a point. Is that point on the line? And well, you keep saying no, but I mean, is it on the line?
Yes.
Yes. So why are you saying no?
I keep thinking about is it if it's on the grid.
Okay, so yeah, it's not on the grid, but is it on the line?
Yeah.
Yes. What about this point? Is that on the line? Yes. What about this point?
Yeah.
What about here? Here? And that line continues forever up and it continues forever down. How many points are on that line?
There isn't a clear number.
You're right, there's not a clear number. We would say that there are infinitely many. There's no way to count them all. There's too many to count. So, Joey, I think part of the confusion you're having is, I don't see a point. The reason that this line exists, y'all, is because there's infinitely many points there. What's making it a line is, notice I have individual points here, but if I put every single point next to each other, what does that end up creating? A line. That line is created by infinitely many points together. What I want, though, are clear points that are on the grid so that I know what the coordinates are. So I found this point here because it's on the grid so I could identify the coordinates of 5, -2. The grid, the intersection of these coordinates right there. And so now I'm going to continue until I can find the next intersection of the grid. Tell me when to stop. Right here. And the grid's right there. That's a little bit below the line. Let me start over. I know it's hard to see because it's kind of small. Right here, you think? If you look right there, the grid is actually just a little bit above. Notice grid's above, grid's below. It's right there. And you have to be careful and make sure you're really paying attention to that grid. But, Joey, does that make sense? Like, those are points, but that's the point I want because it's the intersection of the grid. There's infinitely many points. I want the one where the grid intersects. Alright, I'm going to have to sit down with you in a second, dude. Because I just think you can't quite see it from there. But it's the intersection of the grid. Who has a question about that before I continue? Good? Okay. So, we already talked about it. The rise was 6. The run was 5. And so we use that to find our slope here. But what do I still need?
B.
The B, which is part of the
Y.
y-intercept. I can't clearly see that right now, can I? No? So this may be where you want to create another graph and you draw it and you could draw the intersection to the y-intercept. Personally though, I'm going to go 5 and -2 and I'm going to go 10 and 4 because if I'm adding 5 here and adding 6 here, what number did I need to start with before that?
0.
Isn't 0 plus 5, 5? And 5 plus 5 is 10. So I could keep that pattern going. You with us, Thomas? So then, what number did the y value start with? If I look here at -8 and I add 6, does that give me the -2? So you had to play around with it to find it. You could have drawn that graph as well, but there's my y-intercept of -8, b. So now y is equal to, what's going to take the place of m?
It's the slope.
So 6/5 or 6 divided by 5 times x plus -8. Well, instead of adding -8, what would we usually do? Just -8. That's the equation of that line.
That was far off. Without even getting it, so of course it's far off.
Hey, Joey, you gotta stop being so negative, dude. You are preventing yourself from being successful because you keep getting in your head and telling yourself that you can't.
Gotta be happy about it.
Well, it's not just about having happy vibes, but you gotta focus on the fact of what you can do.
I don't remember the last time I truly happy with myself.
Well, I'm sorry to hear that, my man, but that's not
You gotta talk to
what we
the
want to focus on right now. Let's focus on what we can do, because that's gonna help us find more success and enjoy life more. Okay? So, let's get to our lesson for today. We're going to get back to what we've been working on. What have we been working on? Least squares regressions, where we are taking, does anyone remember, and I need to recover this language, does anyone remember what that graph is called, where we graph those individual points?
No.
We're not playing.
We did get to a movable line, but not that. If I graph these points, there is a coordinate plane. Okay, let's get out our lesson first. Get out the lessons that go with this. It's lesson 1. So Daria, you're looking at the right page. Look at number 1, part A, I think. It's called a what? A scatter plot. So listen, the graph where we graph those individual points is known as a scatter plot. Okay? So Jordan, what's that graph called?
A scatter plot.
There we go. And so one of the things I want to point out to you is this. How many variables are there for these scatter plots? There's 5 points, but how many variables? 2. Huh? So notice right here, one variable is temperature, the other is number of customers. How many variables? 2. Does that make sense? Like you're looking at all those numbers there, but you got to separate the variables from the number of values. There are 2 variables, which by the way, when we write an equation, how many variables are there?
3.
Y and X. Those are variables, things that can change. Okay? So, whenever you have 2 variables, what we would call that is bivariate. That prefix bi means 2. Variate meaning variables. They vary. It's called bivariate data. I realize I haven't used that language. I need to use that language. What we're talking about is bivariate data, and we graph that bivariate data on a what again? On a scatter plot, right? It's on a coordinate grid, but it's called a scatter plot once we graph that bivariate data. And what are we drawing along the data points to approximate those data points? What, Emily, what did you say it was? Okay, so we want the line of best fit. In general, we call them trend lines, but we want the line of best fit, or it's also called the LSRL, which is the least squares regression line, right? That's a little summary of where we've all been, okay? And it's okay if we're not 100% with that language, but we need to look at our notes. Least squares regression line. Okay, that's not where I meant to be. All right, this is where we wrapped up the other day. We missed class yesterday because a lot of us were at the volleyball game. And this is where we're picking up. So we already did this, the range of the data set. First off, how did we calculate range? I'm not going to go back through it. Hey, we need to make sure we're on the right page. It's the which values? Max minus the min for range. This is page, did I put the page in here? M1, or 173 is the page that we're looking at. So you should be looking at M1-73. So we looked at the range of the data set. The range was max minus min. Okay. But focusing here, identify the independent and dependent quantities and their units of measurement. What was the independent variable? Right, so those spans of how many years though? So remember, we can't put 1957 and 1961 on a graph, but we can put the number 1. That's the first span of 5 years. That's the idea. What's your question, Joey? Hey, Joey. That doesn't tell me what your question is, man.
I don't know what my question is.
Okay. You understand that this is just the first interval that's up here, right? It's the first span. I mean, is there anything before this?
I don't see anything for it.
So then that's the first one. Okay? This one is the second. That's it. So those spans are my independent variables. What's my dependent variable? Right? So the average temperature in degrees Fahrenheit. This is important for what we're about to do. So you need to have your variables defined. If you don't have your variables defined, the next part of this is really, really hard to do. That's number 2, yes ma'am. Right? That's the independent and dependent quantities, right? The independent and dependent variables, and we have their units of measurement. We have the spans, and those spans are every 5 years. The average temperature is degrees Fahrenheit. Okay. Just going to erase this part about range. If you still need to take those notes for number 2, do that. But,
Wait, Mr. Kenny.
yes sir.
It actually spans of 4 years.
Say again.
It actually spans of 4 years.
Is it?
Because 1960 and 1966, not 4 years.
So look, check that again. 57, 58, 59, 60, 61.
I'm so
You have to count. Okay, listen. The difference in those numbers is 4, but that doesn't include the number 1957. 1957, 1958, 1959, 1960, 1961. That's 5. How many years is that, bud? Okay, it's 5 years. What you're used to doing is just subtracting them, which tells you the distance between them, but the distance between them doesn't include that first number. And so when we're counting like that, we would have to count that 1. I see where your confusion's coming from, but that's why. If you count it out, it's 5 years. Okay? Okay, so let's look at number 3. I'm going to go ahead and tell you. Don't sweat number 3. This is coming from an Algebra 1 textbook where they talk a lot about functions. We haven't talked about functions because we're focused on geometry. But we need to look at the data. Number 4 says use technology to graph a scatter plot demonstrating the relationship between time spans and temperature. So, let's pick up our calculator. What page do we need to create or add so that we can put that data in there? Alright, create a list and spreadsheets page on the calculator to put that information in. So, add a page, list and spreadsheets. If there's anybody in your group who's not sure how to do that, check in and help them. But it's control, and then, is it doc that's add page? Control doc is how you would add a page. Brooklyn, have you added a page yet? What? Hey Jordan, have you added a page yet? List and spreadsheets. I think that is is it number 4 or 5? Number 4 is list and spreadsheets. You need to go there first. What should you put at the top of the first column? I would probably do spans because that's what we're actually putting in, the spans. And then what's the second column? Temperature. We can even just put temp for T-E-M-P for temp.
Is this it? I got you. Look, press the phone.
I will come around in just a second and help. I just need to get my numbers in here.
Got you. So look, that's the home button, right? Home button. Press 1. Press 4. That should say.
So you don't want to need a label up here, but then you have the numbers right there. What do you do? Come on, man. Label the columns, get your numbers in there. Jerry, that doesn't look like the right stages. Do what thing? Set it wrong. Well, you need to check your numbers again. You should have 12 on both. You missed one of them. Go back through and check. Missed that one, number 3, 7.196. Keep going. Make sure once you put your last point in that you hit enter. If not, things will get messed up when you try to graph in a second. If you are waiting on the class, make sure you check through your numbers, make sure you have them all in there right. We will start in just a minute. Well, then you need that outlook. Okay,
Oh, I'm not.
not quite. Raise your hand if you need just 30 more seconds or so. Okay, let's get those numbers in there.
I'm like,
Yes, Joey? I mean, did you type the numbers in the column, my man? Okay, then you're good. Do they match up? Yep. Last one in the first column has the last one in the last column, or second column. Okay. What do we now need to do though to be able to graph this data? Okay, so how are we going to make that scatter plot though? So remember, we need to add a new dot or a new page. So you want to hit Control, Doc, and what kind of page? Data and statistics. Data and statistics is where we would add a page.
says
Hit enter. Enter. There you go, keep going. Okay, so you're gonna go to add data and statistics. Now, we need to be careful here. On the x-axis, what's gonna go there? Why would spans go there?
Good question.
Okay, we're trying to answer it, pay attention. So remember how we defined what the independent variable was? The independent variable, say again, Joey? Yeah, dude, you wrote it down, hopefully on that page in front of you. The independent variable was the spans of 5 years, right? So we want the spans along the x-axis, which is the independent variable. And what do we want along the y-axis? The temperature, which was dependent, right? One of the things I will point out, and I do want to remind you, is this is not always true, but please note, this is almost always going to be true. Which variable goes on the left? On the left. Independent. The independent variable almost always will come first, and then the dependent variable. The only time that won't be the case is if someone's trying to test your ability to recognize independent and dependent variables. But the independent variable is almost always on the left and dependent on the right. And so when I graph this, what does that graph kind of look like?
Well, middle.
One dot.
There is one dot that's a little off, but overall, could I fit a line to that data pretty well?
Yes.
One dot's off, but everything else looks pretty darn what?
Spectacular.
What's the shape of that?
Linear.
Linear, right? One dot's off, but every other point looks pretty darn linear. Okay? So now, what does the question ask us to do? Okay, so what is number 4, use technology to graph a scatter plot demonstrating the relationship between time spans and temperature. What association do you notice? What did we just say it looks like? It looks linear, right?
So it's more like a straw.
Okay, well I'm telling you, the shape is what? Linear. So what should you write under number 4? It has a linear association. Well, that's a good question. So if you look at this graph, when you read a graph, it's just like a book, meaning you read from left to right. If you read from left to right, is that increasing or decreasing? That's increasing. That would increase, meaning the slope is positive, right? That would be an increasing line. Huh? I'm sorry you feel this way.
Mr. Good, I need to use the bathroom.
Wait a minute.
You can't, buddy.
Why am I
You should have done that before class started. I'm about to. Cameron, what's wrong? Or Coda? What? Because you messed up the y-axis. Okay. So, we've already answered number 4. I don't care as much about number 5. No, I already told you that that's based on an algebraic concept that we're not studying. So what we're going to jump to is now number 6, which number 6 says use your graphing technology to determine the regression equation. I don't care about you sketching the data points, but I need you to do number 6 where you get that regression equation. How do you get what? Hit control from his escape. Hit escape. There you go. Oops. You want temp there, go here, you need to add span. There you go. But if she did it for you, you're going to have to do that on assessments. You better make sure you actually ask how she did it. Okay? So let's get
get your regression equation in there. How are we going to graph that least squares regression line? Hey Ethan, I just said I don't want you to graph, I want you to do number 6. I need y'all to follow directions. Okay? Does anybody, for 1 second, listen, does anybody know a task that we've done in class that walked us through how to graph the least squares regression line? The squared up task is where we covered graphing the least squares regression line. But looking at the calculator, what button would I need to press to do pretty much any operation? Menu. We always start with menu for operations. Then what? So we're trying to analyze that graph. Jordan, focus. Pick up the calculator, dude. So menu, then analyze.
How you get that? That first menu.
You should have been following along. I'll check on you in a second. Do you already have the graph done? Okay.
I got it.
So, menu, analyze, we want a least squares what? Regression line. If you know the vocabulary, it's going to tell you where to go. We want a least squares. So I'm going to go to number 6. And I want a least squares regression line. I recommend you doing number 1 because you're used to y equals mx plus b. It's the same thing, just slightly different. It's the same function though. So write down your equation for number 6. Hit menu, analyze. Regression. No, that one. We need to check your data again.
I got way more numbers than that.
All right. So, what should we write down for number 6? That equation.
Well, that's not what I know of.
I did. I think I got way more
Okay.
numbers.
Well, that's a good question. Did you just get more decimals than that, or a completely different set of numbers?
Well, you did it over
Okay,
there.
hey Joey. Actually, so let's look at this. Hey, I need y'all to stop bickering and listen. So look at that number. I don't know exactly who this is, but 0.125934. Is that,
Oh, that's me, gang.
a lot of y'all have this, look. Is that just a rounded, or is this just a rounded version of that? Yes. So it's okay, it's the same thing. This that I had, I just didn't have as many digits on it. And then I think I had 56.9. Isn't that just a rounded version of this?
I ain't trying to make it like it was a problem. I was just letting you know.
I'm just letting you know that it's okay. If it would round to give you the same number, stop stressing it.
Yes, sir.
So, I would do those 0.126x plus 56.9 because that just has less that I have to write. Now I will say this, listen, I recommend 3 decimals, or 3 digits I will say. So 126, 569, make sure your decimal's in the right spot, but 3 decimals, or 3 digits.
My stomach hurts.
I'm sorry, buddy. But right now I'm trying to teach you math. Hey Jordan, I'm up here, not over there, pay attention. So, number 6 says use your graphing technology. Oh, we already did that. So, y. Does anyone remember what I always put over my y to indicate its information? Little hat, okay? So we'll carry symbol y hat equals 0.126x plus 56.9. So, Do you think that this line fits the data well? We didn't graph that data by hand, but if you look at your calculator, does that graph or does that line graph the data well or fit it well? Yes. That's the whole point about a least squares regression line, that it's also the line of,
Least regression.
yes, but there's another word that we use for it. It's a line of best fit as well. The least squares regression line, hey Joey, I've said it multiple times, man, that the least squares regression line is also called a line of best fit.
I'm the first time I've ever heard you say
Well, I said it 3 times earlier today, and other students said it in class today.
that.
Today, literally at the beginning of this lesson.
I don't remember.
I'm sorry, but it was said. Okay, so the answer is yes. Least squares regression line is a line of best fit. That least squares regression line is in fact a line of best fit. So it literally is minimizing the what do we look at and square it up? It's minimizing the sum of those squares, which is a part of the residuals, right? So it's minimizing those sum of squares. So we want to recognize that. So let's look through number 8 together. So for each expression from your linear regression equation about global temperatures, write an appropriate unit of measure and describe the contextual meaning. Then choose a term from the word box here to describe the mathematical meaning. So I will point out, they're using f of x, cross that out and put y hat. You will learn about f of x next year in Algebra 1. Or whenever you take Algebra 1, you will learn about f of x. Okay?
Why would a hat?
The y with the hat, yes sir. Right? Notice it's based on what we wrote in number 6. So y hat, that y, that dependent variable, what unit are we talking about there?
That's the question. Why hat?
1.1.
Listen to my question again. Really, you're not that funny. But it is the predicted y, but guys, what is y representing?
Eagles event on speed.
Y is not the independent variable, it's the dependent variable. So remember, the y always goes along the vertical axis. That's my dependent. And it's my what? It's the temperature. So what unit went with that? Degrees Fahrenheit. Was it the y,
I ain't seen it.
huh?
You froze. I thought
No, it wasn't because of you. It was because some people in the back need to focus. So, the y was the temperature. It was the degrees Fahrenheit. So the contextual meaning, what we mean by the contextual is the context. Meaning, in the story, what is that representing?
Temperature.
So the temperature. I'm running out of room, but temperature, right? The units were degrees Fahrenheit. The contextual meaning is temperature. Trent, if I need you to sit up here in a second, I will, but I need you to focus, man. You're not taking notes and you're talking to people back there. So looking at these options over here, would the mathematical meaning of y be my input, my output, my rate of change, or my y-intercept?
Because the y-intercept is
Input value.
Hold on. Hold on.
that's the garbage.
Okay. What equation is this the setup of? Y equals, thank you, the y-intercept to be 56.9. That's my y-intercept. Do we substitute in for x or for y?
Yes.
So x is my, I'm looking at these word boxes, this word box over here.
Rate of change? No. It's not like we-
Y-intercept.
It's not the y-intercept.
Guys, pause. We literally just said that B was the y-intercept. Like, I don't get frustrated with people not getting things except when I literally just talked about it, so that means that you weren't paying attention. The y-intercept is B. Y equals mx plus b. Guys, rate of change is also called what for a line? A slope. So my slope is my rate of change. So it's only the input or the output. And do you substitute in for x or for y? You substitute in for x. So x might be my input. Y is always the output. One or two of you might have said that. But most of us did not recognize that y is an output.
Well, why is that output?
Because you substitute in for x to get out the y.
Oh, yeah, we're not ready before.
You should have gone over it in 8th grade a good bit.
I never went over any of that.
I'm sorry you feel that way, but Devin, y'all did talk about this in your classes to Marlon? Barely. So like, we may have missed it in our classes, but I promise you that was an 8th grade standard.
I was I barely.
Okay. Hey, pause. I'm telling you now. Okay? Y is an output. All day, every day. So 0.1259, notice that's the 0.126. First off, what is that mathematically? That's the rate of change, also called the slope. You may see this in future classes. If you ever see ROC, that's just rate of change. It's an abbreviation for rate of change. That's my slope.
I thought it was like a robot. Like ROC abbreviation sounds like
Okay. Now, we did this on the squared up task where we actually kind of paid attention to the contextual meaning in the units. But remember, we just said that the rate of change, the 0.126 is my slope. But how do I calculate slope? Because this is what I need in order to interpret that value. Okay? But what's another way to say that?
Changing y by changing that.
Okay, I need you to hear me very clearly on this. I am walking you through how to interpret slope and how to interpret y-intercept. We were supposed to have an understanding check today, and I'm moving it to tomorrow because I know that you need this information, so I need you to focus. The slope, when we're interpreting slope, we are looking at the change in y divided by the change in x. However, what is that 0.126 being divided by?
1.
It's always understood to be divided by 1. Right?
It is.
Every number can be divided by 1 and it stays the same.
Yeah.
Okay. So every number you want to write is divided by 1. So pay attention to that because when we're talking about units and contextual meaning, that's going to matter in just a second. So y. What are the units for y? Okay, so really what we're looking at is 0.126 degrees Fahrenheit. What's the x?
years or span.
The span of years, right? So 0.126 degrees Fahrenheit for one span of 5 years. And so that's what units we would use up here. It's degrees Fahrenheit per what? Span. So this is that average temp per span of 5 years, right? So that's how much the temperature is changing every 5 years. It's the average change in temperature every 5 years. I'll write this somewhere else in a second. It's not too much, you expect too little.
What's that second one say?
Okay, so it is the change in temp per change in spans. Right, that's what we're talking about, that change in temperature per the change in spans. Joey, what are you confused by, dude? What can
I'm trying to figure out what it says in that unit part.
Degrees Fahrenheit.
Degrees Fahrenheit.
Degrees Fahrenheit divided by span. Degrees Fahrenheit per span.
I thought it said oh.
Yep, degrees Fahrenheit. X.
Question was that's span.
Thank you. The X we already defined was the span of 5 years. The contextual meaning. Span of 5 years. Don't make it more complicated. And mathematical meaning. X is always our input. So 56.863. That is the y-intercept. And y has degrees Fahrenheit, right? So the unit would still be degrees Fahrenheit. Contextually, this is the, it is the temperature still, right? It's an initial temperature. Because isn't that what a y-intercept is? Is the y value at the beginning or at 0, at x of 0? And so mathematical meaning, the y-intercept. All right. Next to your graph, I want to take a second to actually interpret the slope and y-intercept, because this is something you have to do tomorrow. Just letting you know that now. So here's the equation. What I will tell you on the understanding check is to interpret that equation. So you might want to write down this note, interpret the equation, means explain the slope and y-intercept. So interpret the equation. All right. So we've already started talking about this sum. What is my slope again for this?
0.26.
And whenever we're interpreting this, we want to understand that that 0.126 is divided by 1, because that gives me, how do we calculate that again? Remember, that's the equation. Rise divided by run, but for this, we want to talk about it as the
Change of y divided by change in x.
and that's important. Remember, we just defined what y and x are over there. Y was the temperature. X was the span. By knowing this, I can now interpret this slope. I need to pair my numbers with my variables so that I can interpret this. Because 0.126 is a change in what? Y, yes, but in the context. So we now need to go to the context of the problem. 0.126 is a change in, is it Y temperature?
Yes.
Okay, so that's a change in temperature. This 1 is a change in the span of years, right? So you need to connect it with your variables. And then, do you remember which variable we always start with? You actually always start with the independent, which is x. Remember, the y depends on x, so we start with the